Okay, we got quite a bit of work done on the mill this morning. We did figure out the tool changer. Like I said in the previous video, it was just a phasing issue. That particular single phase motor that runs was out of phase, and basically that made it rotate backwards. I'm really surprised it even worked or didn't damage anything, but it works just fine now. I did cut the first chips. Basically I just did a really simple program. Let me go over and grab the part and I'll show you just the basic operation that I did. Okay, drilling a hole. Basically I used a piece of tubing. That way I had a little bit of leeway to make sure that I understood how the work offsets work on this machine. It worked great, and basically what I did, I use this on my mini mill a lot on a jig plate, but I really like these clamps. They're inexpensive and they're easy to get a hold of. They're from Vertex. And they're really simple. A lot of folks I've seen have actually made these. Are fairly easy to make. But basically you just slide these up in the slots and you tighten down this rear screw, which comes out of the bottom, and it presses up, and then just make sure that your workpiece gets a hold of that foot. When you tighten that down, it's going to compress inward and pull down. These work really good. Okay. So basically I just went through the manual, looked how to do just a drilling cycle, which is fairly easy. It looks like the rigid tapping's the same that I've dealt with before. It's pretty easy to do as well. I've got almost all the holders in and tooling put up. One of the things I found is my particular Cat 40 fixture didn't work very well with the BT40, and they're supposed to be identical, but the way that they designed the clamp, for whatever reason, I guess it was an El Cheapo, it didn't work very well. So I picked another one up on Amazon or eBay or somewhere for like 30 bucks, and finally got started putting my tooling in and starting setting my offsets and actually building a tool library. Right now I've only spent about an hour, and I've got maybe 3 tools that are ready to go and run. This morning I did put all the tool changer back together, put the cover back on, did another wipe down of the machine. I'll probably do that probably every time I use it until it's kind of a lot cleaner. The tool changer I actually have been using just a little bit of purple power in WD-40 to try to get all that old coolant off. I'm really not as worried about this down here because a lot of this will come off. If you put a fresh load of coolant in, it may degrade your life of the coolant, but that coolant will actually soften all this, and it'll be a lot easier to clean once you start running the machine. At this point, what I'm working on right now is pulling my coolant pop taps out. The machine came with just the plastic ball on the bottom. I'm going to pull those out, measure and make sure I get the right size, and I'm probably going to get 4 or 5 of them. It actually has another tap up here where you could actually tap and put 4 in. I did mount the coolant pump, and it does work. It's a 3-phase unit as well, so I'll need to check rotation when I actually put a lot of fluid in it. I wasn't able to actually pump fluid through it. I just know that when you turn it on, something rotates back there. But it's exposed, so I mean, even if I have to take it apart, replace it, whatever, it's really easy to get to. I double checked level this morning. The machine seems pretty well settled. I'll probably check it in about another 2 days just to make sure that it hadn't moved. Still look good on all the bed. The machine doesn't have any twist or torque in it, so that's good news. Because it's kind of a pain. I don't know if you're familiar with leveling these machines, but basically what you do is you try to level them front to back with the front and rear screws, and those center screws are designed to basically try to take the twist out of the bed. So that's the last thing you want to adjust. Got that done. All the covers are back on the machine. The American rotary converter, I don't even realize it's there now. Pretty much it's just start it and go. It hadn't given me any issues. This monitor is working much better now that I've actually adjusted the pots on the back to get all of the contrast and size and everything correct on the screen. So I think I've tested pretty much everything on the machine with the exception of actually flowing coolant, which I'll do sometime hopefully next week. I'll actually initially load it up with cleaner, let that run through the machine, and then load up a fresh batch of coolant. I do have the first tools that I started with are mainly my 3/8 inch, half-inch carbide, steel, aluminum things. I was a little disappointed. I actually got a face mill shell holder, and it fits. It's the right arbor size, but the button on the bottom is a little bit too tall for face milling. So I'll either have to machine that button down, which I really don't want to do, or just get another holder, or get a larger face mill with a deeper socket. So I'm going to keep going here just for a minute, and if I see anything, I'll mention it. But I'm going to go ahead and take out these little coolant bungs, so that I can get replacement coolant tubes and the bung to go with it. And that's basically what we're taking out. That was what was left of whatever coolant system was on it before, and it was probably just the blue and orange regular coolant tubes. And this is why you want to flush it. I just pop this out, and there's quite a bit of goop up in those tubes. I've already blew a little bit of air through the lines. I mean, the air's making it through, so I don't think the coolant's going to have any issues, but it'll be something I'll definitely be checking for to make sure that I got good coolant flow. Okay, those are out. Another thing I did, this has one of the standard halogen lights on the inside. One thing I did this morning, just real quick, is the ball section that actually you tighten the hex wrench down and the spindles on the ball section. There was I guess they'd taken it off and lost the little spacer. I went over to the lathe and just machined one out real quick, put it back together, and it works just fine. It's all locked in. Before it was kind of bobbing a little bit anytime the machine would move. The machine, the base is relatively stable. This, the metal structure, it's just sheet metal. That's what that light's attached to. So, any little bit of vibration that you have gets translated to that light, and it's on an arm that's about, 3 feet long, if you count all the sections. One thing I've been doing pretty often, machining is usually messy. I know a lot of folks that buy a brand new machine. The first 5 years is pretty easy to keep clean. After that, the paint starts chipping off. Most of the paint coming off of this machine isn't much as chip load as it is just the coolant has eaten the paint away. But one thing I've been doing is kind of just the control section. I kind of try to wipe down because I'm putting on and off gloves, cleaning, touching, that kind of thing, and you just want to try to keep it clean. And eventually it'll all be fairly clean, And the biggest cleaner I've been using is just simple green. Back on the tool holder, purple power, you know, crazy stuff. That is never probably going to see enough coolant to actually melt that stuff away. So I've been using some cleaner back there trying to get that cleaned up. Another important thing is just, you know, try to keep a coat of WD-40 over everything. There's water involved, especially before I get coolant in it. There's no rust inhibitors getting sprayed all over the machine. So that's the stuff you want to look for. Okay, the machine's ready. That was a whole boot up of the machine. And the first thing you want to do on these, this is a Fanuc Series 0-M or O-M. There's some question on whether it's a 0 or no. I think it's an O. Basically, the first thing you want to do pretty much every time, this doesn't have absolute encoders, which is a battery backed up absolute encoder. So every time you start the machine, you have to zero it. It's real easy to do. It does pay attention to your feed rates, but I've got those pretty much wide open at this point. But you basically turn the axis select, hit positive, and then moves the table. It'll basically move to a point and then slowly move to 0. And this is going to be the machine 0, not any other. I mean, it's not working off of any of our work coordinates or anything. This is finding the machine 0. And you want to do that for each axis. And I found you can actually do them sequentially, like I just basically did both there real quick. It only takes a few seconds. Okay, so now the machine is 0. This is where we would actually load a program. And I've been playing with this box. I just wanted to mention it. I think it'd be really cool if there was an open source version. If I had time, I would start working on this because this is really interesting. But this box actually is fairly well built. I think this is the Ossus box. It's a Titan. I mentioned in the other video, but I've had a little bit of time to play with it in both directions. Drip feeding, sending programs to the local memory on the Fanuc controller, and also backing up all of my data. And I'm not sure that's going to come into the camera, but we'll try. So basically in the memory setting, I've got all my parameters saved that are on the machine. Some important to do. I've got several files. And it basically has all the parameters. So if I ever need to upload those back in the machine, it won't be an issue. And this is just basically a standard directory. And also you can plug in the USB key, which is what I've been playing with, is basically taking something out of Fusion 360 or what have you, putting it on a USB key and hitting go. This thing's really well coded as far as, you know, USB key in and out. You know, you really don't have to unmount it or do anything. It may not be good on it, but it seems to work just fine. And the really cool thing I like that I mentioned in the other video is this machine has a 100 volt out on its receptacle, and this works just fine with 100 volt. The rating for the power adapter that came with it is 100 to 120 volt, and it's got a nice magnet here. So they've got it pop it on the side, and it's on my controller, and everything swings out all together. The cable actually goes in right here, and the electrical connections also right here on this swing out panel, so it all stays together. Basically, shutdown's just as simple. You turn the NC control off. My particular application, I got a rotary converter, so I'm going to go back and turn the main power off. Okay, now we're back off. Some of the things I've learned about this machine, one, it doesn't take a huge amount of air. I've got just a little portable, you know, one of the little half-hot portable air compressors, and it seems to do fine keeping up with the machine. Another thing, if you're looking at any of the older Fanuc controls, is batteries. I talked about this in the other video. Basically, this particular machine has a little black panel on the very back of the electrical panel. You need to make sure the machine is powered and on before you go changing those batteries, or you'll lose everything in your memory, including your machine builder data, which would be catastrophic if you don't have a copy of that. But basically, you need to replace those batteries. Looking at the manual, it says monthly. There's also an indicator on the front. There is a company out there, I think, that makes a lithium-based rechargeable. So basically, it recharges every time you turn on the machine, which will be nice. I'm looking at that, or if I get bored, I may just design one. It's a pretty simple application. It's just a lithium recharge at the correct voltage. There's actually, on some other machines that have absolute encoders, there's also a lithium battery that's non-rechargeable that actually keeps the encoder positions stored. This machine doesn't have that, but if you do have that, it's usually a box similar to the D-cell battery box, and it's usually somewhere close to that one. All the ones that I've seen have been basically stacked on top of each other. You'll have the one on a pi, and then you'll have one down below. And you'll want to make sure you change those with the machine on and it powered. I'm going to try to get to a couple other things today. One being, I want to try to basically get all my basic programs on here. The first project that I have is just some plates that I need to make. That'll basically be a drilling and tapping operation. Really simple. I want to play with getting that on the memory. That's something that I do make a set of those every year. That's the plan. And I want to have those just on the machine. That way, when I want to create those, I can. The work offsets, I think I have figured out. It's always a little confusing playing with a new machine. This wasn't as bad as I thought it was. I looked at the manual, and it confused me a little bit. But once I got in there and actually looked at put the work offset in, and pulled up the position page where it shows you all the relative and work offset and machine positions, it kind of started making sense in relation to what this machine's doing. The Haas was a little different. Looking at the Haas, obviously it seemed to me like it was easier. But now that I've played with this, I'm not sure. It's just not different. I don't know that it's any easier. Feed rate wise, this machine does about 1,000 inches, so it's pretty quick for rapids related to what I had over the old mini mill. I know the new mini mills are blindingly fast, but the machine that I had was relatively slow. This is a big upgrade as far as table space, work area. I got a lot. I have a 20 tool changer, and the biggest thing that I like is I can kind of see how the chip load works. Basically, there's little fan pieces that are in the back that kind of fan the chips out, and they basically end up in these chip trays. The mini mill that I had, you had to climb up in it and scoop out with your little sandbox shovel and bucket, and that wasn't fun. And that's one of the main reasons that I got a larger machine. But I hope you like the videos. We'll probably get to some machining here shortly. The purpose for getting this is so that I can continue making enclosures. And I'll kind of give you an idea if I can find it here. I think it's down here. Okay, so when I had the mini mill, I actually had this made by a family member on his CNC router while I didn't have a mini mill. But when I did have the mini mill, I had an aluminum enclosure that would actually encapsulate this. Now this is the mini much for the razor. you know, it's conformal code. It's a reality is you could probably just put this in a razor and you would be fine. But a lot of folks want something, you know, to protect it and enclose it. And the biggest important thing is you really need that for mounting. I have a little bit newer design. I've been tweaking it mainly because I want a version that actually has a lid that's semi shaped like the tube on the roll bar. So you can basically take this and you know, if you could imagine this was in aluminum encased, that you could actually lay it up against the roll bar and it would have little guide slots where you could actually put a pop clamp or just zip tie it on, and that would make for a little bit easier installation. The one that I have now actually has bolt holes, and you bolt that to the firewall, which takes a little bit longer, requires some climbing in and out of the razor, and that would just speed up installation. It would look a lot cleaner. But that's the main reason to get it. And I have a lot of RS stuff that I do that is you know, aluminum enclosures, and I do quite a bit of those in a year, just building those. So that's the plan for what I'm going to use the machine for. I'm sure I'll use it for other stuff. I still have over on the other side of the shop, I've got a manual lathe, and I still have the Grizzly vertical horizontal mill. I still use it quite a bit. And then, you know, obviously I've got drill presses, bandsaws, plasma cutter, welder, etc. I don't use those as much these days because I'm not fabricating as much stuff. But this is mainly going to be used for electronics enclosures. Okay, I hope y'all enjoying the videos. If you see anything that might help out on the Fanuc, drop me a line. Again, this is a new control to me. I've learned quite a bit in the past couple of days. There's not a huge amount of documentation. Most of the stuff that I've learned is from forum posts or the machine manual, which is very sparse, or the Fanuc operator's guide. But you really have to dig and this, that, and the other to get to it. I don't plan on doing a lot. I know enough about G-code where I can do a program by hand, but basically I plan on using you know, CAD-CAM to do most of the programming. Plan for the day is to try to get the chip trays on top of these coolant trays, and then get all the plumbing hooked up. There's a pipe that connects up, and I'll be working on that probably for the rest of the day. They're fairly heavy, and I've got the coolant trays clean, but the chip trays are not clean yet, so it's time to go out and pressure wash those. I hope you all liked the videos. Thanks.